Okay, again, you saw that to do any kind of algebra, what you want to do is write vectors in component forms. Okay? So what I'm going to show you is a trick that you need to be aware of. Okay? So I'll just do components of one vector. So, okay, I can do either this one or that one. All right, let's do this one. Now, before I do this, you guys remember from your trigonometry classes, so for a right angle triangle, if this is A and this is theta, the adjacent component, this is A cosine theta. That length is A cosine theta. And what is this guy? A sine theta. Everybody know that? Okay. Everybody good on that? Okay. So now let's say this is the vector D. Okay. So in your formulas you saw the x component of D is given by magnitude of D cosine of the angle theta. That angle is measured counterclockwise from the x-axis. Okay. In this problem, they give you this angle to be 37 degrees. And the y component is D sine theta, okay, where this angle is theta. So this is 20 times cosine. What would theta be? In our case, theta is 143 degrees. And d sine theta is 20 sine 143. Okay, and if you guys do these things in your calculator, this works out to minus 16. And 12. Okay. So what does this mean? The vector D is minus 16I plus 12J. Okay. So what that means is you go minus 16 units there and plus 12 units there. Okay, so the vector is in the second quadrant. Okay, but oftentimes it's more convenient rather than figuring out the angle counterclockwise from the x-axis. When you have this, just figure out these distances. Okay, these lengths. This length is d sine 37. This length is d cosine 37. Okay, so let's do d sine 37. 20 sine 37. You will find it to be 12. D cosine 37. 20 cosine 37. And you'll find that to be equal to 16. Okay, so the length is 16 units. But you can see that this is pointing in the negative direction. So if you use an acute angle, you have to put in the sign by hand. Okay, so D, the vector from this is minus 16I plus 12J. Okay, so try to do the components that way. Anyway, in all these problems, you'll have to figure out the components of a vector, okay? And become good at that, okay? So then you guys can figure out the rest. So you know pretty much how to do this guy. You figure out the components of A, figure out the components of D. Any of this algebra that you need to do, you have to figure out the components. Figure out the components of F, and then add all of them. Yep. You guys comfortable with that? Okay. This problem is similar to that. Does anybody want me to do one of these guys? I can do this, which won't take too long. Do you want me to do that? Everybody good with that? You want me to do it? Okay. Everybody good with that? Okay. All right. So here's a vector. How many dimensions is this? 3. X, Y, Z. So this is a 3-dimensional vector. So here are 2 displacements, and they want you to calculate this. So let's calculate D. D is 2 times A minus B. Okay. 2 times 3 is 6. 6 minus 2 is 4. 4I. 2 times minus 4 is minus 8J minus 3 minus 11J. Who wants to do the K component? You in the end? Hello? You tell me, help me with the Z component. So 8, no, 8 plus 7, 15K, okay? All right? So again, whenever you want to do algebra, you want to have the vectors in component form, okay? All right, so let's say I give you this equation, A equal to B. How many equations is this? How do you say 2?
Or it would be the same equation, just 2 different sides.
So 1 equation? Okay, so it actually is depend on the number of dimensions. If you're in n dimensions, that is n equations. Okay, so let's say we do a 3-dimensional equation. So when 2 vectors are equal, AX, AY plus AZK equal to BX plus BY plus BZK. 2 vectors are equal to each other if the corresponding components are equal. So this is really, if this vector is in 3 dimensions, it's really a shorthand for saying AX equal to BX, AY equal to BY, AZ equal to BZ. Okay? So that's really 3 equations. Okay. All right, so keep that in mind. So that will be useful when you do the next problem. All right, so here is the equation. They tell you that find the unknown constants A and B such that, so A times D, A and B are scalars, okay? So this is saying this A times D plus B times B plus A equal to the 0 vector, okay? So it looks like it's one equation and you have two unknowns and you should not be able to solve it. But we just learned that these are two-dimensional vectors, so the x component of this is equal to the x component of that. The y component of this is equal to the y component. So this is really two equations, and you can solve the two unknowns. Okay. So what this equation is, a dx plus b bx plus ax equal to 0. Remember, the 0 vector is 0I plus 0j. And a dy plus b by plus ay equal to 0. So this equation is really these two equations. Okay. And now you have two unknowns and two equations, and you can solve this. All right, so let's fill these guys out. A times 6 plus b times minus 8 plus 26 equal to 0. So 6a minus 8b plus 26 equal to 0. That's one equation from the x component. And from the y component, you have minus 8a plus 3b plus 19 equal to 0. Okay. And now you should be able to solve this. So you guys know how to solve this thing? Okay. So the common factor is 24. We'll multiply this equation by 4 and this equation by 3. So the top by 4 and this equation by 3. So 24a minus 32b equal to minus 104 minus 24a plus 9b equal to minus 57. And then you add the two equations, this cancels. 10 minus 23b seven. Okay. And then you substitute that in one of the equations to get a. Okay, so 6a minus 8b to minus 26, 6a minus 8, 6 is 48, 56. Okay. this problem they say find the angle between vectors for these two vectors. So there's problem A between these two vectors and problem B is between these two vectors. So let's do this, the three-dimensional one. Whenever they ask you to find the angle between two vectors, what you want to do is use the dot product. See, here's a dot product. So they're asking you for this angle, and remember the dot product involves this angle. The cross product also involves the angle, the magnitude, but that's a little longer step. Okay, so this is the easiest one to do. AB cosine theta. Okay, so if you want to find this angle, all right, in this equation to solve for theta, what would you have to know? You would have to know A, you would have to know the magnitude, you'd have to know the magnitude, and you'd have to be able to calculate this. Okay, then you can calculate that. All right, so we'll do part B. Okay, D dot B, since we have the components, let's figure it out in terms of components. It's equal to dx bx plus dy by plus dz bz. That's equal to db cosine theta. Right, dx bx, that's minus 4. So minus 4 minus 12 plus 1 equal to db cosine theta. So minus 16 minus 15 equal to db cosine theta. Well, what is d? D is the magnitude of d, of the vector d. Okay. So let's figure out the magnitude. And the magnitude is dx square plus dy square plus dz square. That's 4, 16, 21, square root of 21.
Oh, you got 1.
1 square is 1. This is 1.
Isn't it 2 times k?
No, for D, I'm figuring out for D.
Oh, okay.
Okay. So similarly, for B, the magnitude of B is minus 2 square plus 3 square plus 2 square. That's equal to 4, 13, 17. All right, so now,
In the initial one, BZ, BB is 2k times k, right?
no, BZ is 2,
Yeah.
DZ is 1. 2 times 1.
It's 2.
Okay. So this is 14. Okay. All right, so let's all right, so cosine theta is minus 14 divided by length of D and B. Minus 14 divided by square root of 21 square root of 17. Theta is cosine inverse of that. And this works out to 137.8 degrees. Okay, so the angle between the two vectors is 137.8 degrees. Okay. So again, whenever they ask you to find the angle between two vectors, what you want to do is use the dot product. Okay. Okay, we'll do one cross product. And let's pick, here's a vector with, all right, we can pick this one. These are three-dimensional vectors. Okay. All right, before I do this problem, I want to show you something. Okay, so here is A cross B. A, B, here's A cross B. A cross B is perpendicular to the plane containing AB. The magnitude of this vector is given by this formula. The magnitude of C is given by the magnitude of A times the magnitude of B times sine of the angle between the two vectors. All right, now if this angle were 0, what would be the magnitude of that? That is for two vectors that are parallel to each other. So if A, and you took their cross product, what is sine 0? 0. Okay, so the cross product of two parallel vectors is 0. What is sine of 180 degrees? 0. So you have to remember that. For two parallel vectors, the cross product is 0. For two anti-parallel vectors, the cross product is 0. Okay? And so the cross product exists for all other angles. All right, so here are two vectors, and we want to find the cross product, A cross C. Okay, again, I will write down the formula. You guys will start remembering it. AYCZ minus AZ CYI plus AZ CX minus AX CZJ plus AX CY. Okay. All right. So AYCZ minus that. So minus 40 minus 4 minus 44I. So when you write one below the other, it'll, when you do determinants, you will understand this. This is this minus that. AZCX 3 minus 20 minus AXCZ 3 minus 20. So it's minus 17J. And then AXCY 8 minus, so minus 12. So 8 plus 12, 20. So the cross product is that vector. All right, so in this problem, here is the force. Dog is being walked on a leash by owner. This is the force that's applied to the leash. Okay. What is the magnitude of the pulling force? So the magnitude of this force is, of course, Fx squared plus Fy squared plus Fz squared. 98 square plus 132 square plus 32 square. Okay, and you guys can calculate that. Part B says, what angle does the leash make with the vertical? Okay, so here's the vertical. Okay, we'll say a vector k in the vertical direction, and there's the force F. Okay, so this is the angle you want to find. Now F dot K, we'll give it a hat just to, is the magnitude of F. Okay, so let's figure this out. We'll need the magnitude of F. Okay, is the magnitude of F times, what is the magnitude of K? What kind of vector is K? What are IJKs? Hmm? Hmm? Yeah, so what's the magnitude of that? 1. Okay. So 1 times cosine theta. Okay. Now this is also equal to Fx kx. Does the k vector have an x component? does this vector I, j, k, does this vector have an x component? Hmm? This vector is pointing along the z-axis. It does not have a x component or a y component. Okay. So its x component is 0 plus fy times 0 plus fz times 1 equal to f cosine theta. Okay. So make sure you go home and study that carefully. So fz is equal to f cosine theta. So the trick is the following. Theta is fz divided by f. So for a given vector, if you want to find the angle with respect to an axis, all you do is cosine of that angle is the component of the vector along that axis divided by the magnitude of the vector. Okay? So that's the angle it makes with the z-axis. All right, so generalizing this, cosine theta x. If you wanted to find the angle the vector makes with the x-axis, what would this be?
90 degrees.
Fx over f. Okay? And so on. All right, I want to solve one more problem, so I'm going to leave it at that. You guys understand this? Okay. All right. Let's say I want to solve this. What kind of a vector is this? Two-dimensional, three-dimensional?
Three-dimensional.
Three-dimensional. So it has an x component. There is the x component. There is the y component. There is the x component. There is the y component, and there is the z component. Okay. They give you this angle. They give you this angle, and they give you this component, the y component. So for a three-dimensional vector, there's three pieces of information that they need to give you to specify it completely. They've given you this, so this should really be gy. Okay. So find the scalar components of the three-dimensional vectors. So what they're asking us to do is find gx, gy, and gz. Okay. All right, we already have gy, which is 10. Okay. This angle is 45 degrees. So this is a right angle triangle, so this side is equal to that side. You guys understand? So gy is 10, gx is 10. Now all we really have to do is find this, okay? Now this angle is 60 degrees, okay? So what we have to do is, all right, so G, if you look at this triangle, what is this guy equal to? This guy is equal to G sine 60, which is equal to this side. And this is the hypotenuse for this triangle. This times sine 45 is 10. So gy is equal to g sine 60 sine 45 equal to 10. So that gives you the magnitude of the vector g, which is 10 divided by sine 60 times sine 45. Yeah, so the magnitude of the vector is g, and then what is gz? Gz is g cosine 60.
Is sine or cosine?
Cosine. For a triangle like this, the adjacent side is, if this is g cosine theta. Opposite side is sine. Okay. All right, so the three components that we needed to find. Again, for a three-dimensional vector, what you have is you need three pieces of information. They've given you 1, 2, and 3. Okay, and they wanted you to find these three pieces of information. So the vector G is 10, 10, 8.16. So in proper notation, it would be 10i plus 10i, 10j plus 8.16k. Okay.